the presentation that I will give some insight today is what we titled The Future of How Things Are Made. But I have to admit, when I saw what has been done already and what you are introduced to already in the Faculty of Computer Sciences, that is already also dealing a lot with what's happening in the future. So it's not new for you. It's often new for our customers. So many customers are not yet on that stage. But before I go into the future, I want to jump very quickly a little bit back. So Autodesk started a bit more than 30 years ago with basically one software product that was AutoCAD. And AutoCAD was the first software that was, oh, that is nice, thank you. That was running on, back then, on the personal computers. Before that, they were just working computer-aided design on big workstations. And it started with 16 employees, and it was basically the change from the graphic board or the drafting board into the digital world on an affordable device. So not on a workstation for like $100,000, but on something that even every student could buy back then. And but it was a transition of just drafting lines per hand, drafting lines in the computer. So it was not so intelligent back then at that time, but it was a good start, and you could do complex plans. And today, I mean, when you work with our software, you all know that we talk about data-driven design. So design that is done with very much complexity, and we define digital prototyping for more the mechanical engineering, the building information modeling. Those that are in architecture or civil engineering know that term. And when it comes to visualization and entertainment and Hollywood, we call it digital entertainment creation to produce very efficiently visualizations. And so we have basically 4 industries that Autodesk is serving or that we're defining. It's a big industry of architecture, engineering, construction. Then we have manufacturing, and manufacturing also includes product design. It's just as a symbol, this big machine, but it is everything from consumer products to really complex factories. And then we have a dedicated version of automotive or automotive and design. So basically, like this Tesla, all cars are designed with Autodesk software with Alias and also visualized. And then, of course, we have that big field of media and entertainment where we have tools like Maya and 3D Studio Max. And as you may all know, most of the Hollywood movies are with special effects are created with Autodesk software like Avatar or Gravity, where we work very closely with these producers also to make things happen. And interestingly, at Autodesk, we see this visualization part, for example, very important also for the industry. It's not only for fun, it's for computer games, it's for marketing, but it's also for decision making. And if you take that technology on this part of M&E that's going more and more into the actual industries where they're used for visualization for decision making. And I like that little clip actually to demonstrate that. And I know that Evgenia likes it too, because it's about a little example of a Porsche. And that's a virtual, as you all assume, it's a virtual prototype. And so it has different colors, and then it changes into reality, and you don't see any transition. So you cannot see anymore what's real and what's not real. And you can look at it in slow motion, you can look at it on the different reflections, you don't see any difference. And so it's a little clip actually of a customer of ours that does for Porsche these visualizations for marketing, but also for the board of directors, for representing new cars. And so this is where this is going in this direction. What I want to talk about today is about where Autodesk is also working on the next step and on very innovative procedures. And it's about 4 categories. It's about capture. How can we, this is a new part actually, how can we capture things to then have them in the computer, to use them as a basis to start working with them. And the second is the computational part, so computing new objects based also often on existing environment. The third one, what is changing dramatically right now, and you're part of that with all your iPhones and iPads and mobile devices, it's how do we collaborate in future in industry. So that is a portion where Autodesk is also looking at not only how to create something, but there's always needs to be collaboration. And the fourth part is that how we create it, how we fabricate it. And I was in the Fab Lab here over there, so this is also a portion of that, that we have this digital prototype and how do we get it efficiently out of the computer again and use this digital model to basically create things. And if we start with capturing, it's really about new technologies that enable these days easier and easier to bring the real world into the computer. And it's about that these devices are getting cheaper and cheaper. That's a laser scanner. There is photographical methods to bring 3D into the computer. There are these drones. I also saw a drone in the Fab Lab that can capture data even of big surfaces and of construction sites. And so this is a little example just of it's a shock absorber that was scanned as a 3D scan, and then typically it's a point cloud. If you're familiar with engineering definitions, so a point cloud is basically nothing that you can really work with so much, except for looking at it. But Autodesk, this is now an example of our Software Fusion 360, can take a point cloud and can convert a point cloud in an analytical surface. And then suddenly you have that object and you can work with it. And you can build new things added on such an object or even modify it in a certain way. In a much different scale, we have the same with construction sites. So this is a point cloud of a construction site of the International Airport in Denver. And they're using these scanning methods and point cloud methods to constantly surveying and observing the state of the construction site. So where is material stored? Where do they have possibly coalitions with piping and everything? And how do they plan the next step so they can see the progress every week? Maybe they do such a scanning and have a much better overview of the entire construction site. Another example is this factory. This is not a photography. It's actually a point cloud. It looks like a photography, but it's amazingly precise. And this is also used for factory design and for knowing what's going on in a factory and where do they need to optimize and to do changes and to delete objects. So it's really a 3D object. And it's generated, we have customers now, the most innovative ones, that do that every week. They have robots driving on autonomous little vehicles that are driving all around the factory, and they're actually capturing this every day. And they're having every day a new representation on what's going on in the factory. So that is a very new field where the possibilities of computer power these days suddenly enable such possibilities. Then the second one, the real point of capturing information is then being able to compute on that basis and to create new things and understand the things, how we will build them. And you have all been involved in projects where you probably also had that feeling. I had that very often, that if you would have known in the beginning what you know at the end of the project, you would have done many things differently because that's that learning process. And that's the idea of having digital prototypes and computation to create as much as possible a realistic model within the computer before it's built, with all its facets and all its attributes. And so stepping into in that new role, you probably all know that symbol. Anybody doesn't know that symbol? So this is about infinity, and what we're relating to this in this area that you are now actually stepping in as young students is this idea of infinite computing power. And this is something that is just on the tip of being available and starting today to have infinite computing power to work and develop in a different way. If you imagine, today you can rent a CPU for 4 cents an hour. That's, I think, about 2 ruble. About 2 ruble an hour. So if you think of that and you think you have 4 CPUs working for you, optimizing something an entire day, that's about the cost of probably of an espresso or of a cappuccino. And the computing power today, as we look at it, is an asset. It's one of the only resources that get cheaper every day. I mean, it's been with the processing of computers in general, machines getting cheaper and cheaper in relation to what they could do. And computing power is getting cheaper and cheaper. And we can predict today that in 2 years, computing power is much cheaper than today, so you have more possibilities, while actually, most likely, a cappuccino will be more expensive in 2 years. So using that gives us a lot of new possibilities. And so in different fields that have always been very computational intensive. So if we just look at this example, that's a very simplistic example of computational fluid dynamic that, of course, has also been done in a much more precise way, but it shows it very nicely that you can have very easy and tools to optimize the form of cars. And on another example that is a bit more scientific now, it's about simulation mode flow. Mode flow is one of our products for plastic injection and simulation of plastic mold injection. And it's been in the past also with the software that you had maybe you have 3 components. You have the mold temperature, you have the actual melt temperature, and you have the flow rate. And these 3 components define how your product will work. And ideally, you always want to have the lightest and the strongest in this combination, and it always makes an effort to find that. And then you have different variations. And typically, you would have done them one by one, but with this infinite computing power and with tools that Autodesk is developing to optimize it, you can actually look at it from a different angle, and you define what you actually want to get out. And you can have a multitude of variations calculated in the cloud that then give you a most optimized result. And you don't need to wait for it like on a regular computer, days and days till it actually happens, until you get the result. So this leads us actually to that term. So up to now we're defining ourselves in the industry as computer-aided design, CAD. So we're the CAD guys. And but computer-aided, that was always a little bit of a deception. So the computer or the software was aiding a little bit, but actually it was just a tool where you were recording a lot of different steps as you build something in the computer. And the new step is actually to really have the computer generate parts for you. So like this one, this is now an architectural example actually. This is a lot of different variations of a building, and none of these buildings are actually created or drafted in the computer, but it's all just based on what the architect defined as the outcome, as the wanted outcome, and the computer generates, depending on different parameters, different language of the architect, a lot of different variations. But it's not anybody has actually created one of these forms. And then it's up to us, or up to the decision maker, to pick the one that fits possibly the best. That's another interesting example. That's from a Formula One car, actually. That's a bracket from a Formula One car. And the goal is always there, for sure, to make it as light as possible and as strong as possible. And even sometimes in Formula One, they design things just for the conditions of one specific day or one specific racetrack, where they change the car just with the setup of that racetrack. And so our research development team works a lot also with these clientele of Formula One. And so here they took that part. I say we, but it's actually where we as a company, as Autodesk, they took that part and defined. So we have some fixed points. We have the hole in the middle, and we have some mounting points. And then we want to generate the best solution in terms of strength and lightweight. And what then got optimized, the ability of the computer to fulfill those tasks, is actually that you have these 3 steps that also are not constructed anymore. All these struts, they're not constructed anymore. They're only generated as an outcome of the computer. And that enables totally new possibilities in terms of manufacturing and creating things. There's another interesting example that's a heat exchanger. So a heat exchanger typically exchanges heat between 2 fluids, and the goal is always to do that and to run smoothly between those, in this device, between those fluids. And like the F1 example, this is a 3D printed in metal. So that's a metal 3D print. And it has not been designed by a human in a traditional way, but it was calculated with several 10,000s of hours of CPU. And if you remember, I said a CPU hour costs 2 ruble. So this very optimized device was actually generated in a computer for maybe a few $1,000, or how much is that in ruble? Maybe 100,000 ruble or something, which is not much if you think of what in the classic way you would build prototypes, you would test physical prototypes, you would even test maybe in the computer with like our CFD software, but you would decide in the first beginning, so what is my first approach? And here you specify just certain parameters, and the computer actually generates this whole device. And what's interesting too, it's not only computer generated, it even looks very beautiful in my eyes. So it's got even some aspects of art in it. And this is a very new way of looking at how things will be made in future and how we use computer technology in a different way. This is about space planning, so more from the architecture side, where the computer creates a lot of options based on parameters how a certain constellation of buildings should look like, and then it's up to the architect or a group of architects to decide actually and to define, curate what's actually the one that we want to have. But you get more inspiration because you get offers and options that you might not have thought about and that suddenly are generated by the computer. There's another very interesting example with Airbus. So Autodesk is working with Airbus and is discussing and thinking about the future of air travel and how will airplanes look like in the future and what can be different there. And this is just a prototype, so that doesn't fly yet, but it shows also that companies like Airbus are looking at new production options and how can things be produced. And this is also, if you look at that structure, that goes a lot in direction of 3D printing, maybe even very big 3D printing and casting, and having more possibilities to calculate how something will work and where is the real strength. And looks quite fascinating. I love flying, because I need to fly a lot for my job, so it would be bad if I wouldn't love flying. So, but this is a very, very interesting idea that you would have airplanes in the future that look like this, and where you have actually a totally new view on how things look like. So that was a bit of the section of computation. So this is all only possible if teams work together in general. So none of us actually works, or as a student you may work on your thesis project on your own, but ideally you would also work there together with in a group, in a project-based learning group. So that's the same in companies. Companies, you know, often work totally international, big corporations anyway, but also if you just take big building projects where many, many companies all work on one project and have to exchange data and have to collaborate. And this is the same also in mechanical engineering. So I want to show a little bit of that, of our idea of collaboration with a new software that is available for you. It's in the internet and it's free for students too. That's Fusion 360. And Fusion 360 is a mechanical and industrial design software at the same time. So a combination of mechanics and industrial design. And what's interesting about it is the fact that it's the first completely cloud-based computer-aided design product or development platform that basically enables two things. First, it taps into that possibility, what we're talking about infinite computing power, because it is based on the cloud. It has direct access to the whole cloud computing power to scale operations and to have things running that are difficult on a single computer. And in the second aspect, it's a cloud-based environment, so it's a natural hub for collaboration. And everything in the cloud is about, a lot of things in the cloud are about collaboration, about, you know, like Facebook is cloud, Dropbox is cloud, so all these elements or these technologies and services today, and there is many business services that are based in the cloud. So it's consequently that also developing things will move into the cloud and will use a lot of these cloud options. This is an example of Fusion 360 with a bicycle frame here. And Fusion 360, because it's in the cloud, it runs on multiple platforms. So it runs on PC and it runs on Mac. It runs even on browsers up to a certain extent. And what's important about it is it shows where the future, where we're going in terms of software application. And Autodesk is definitely going. And what it does, it works on form, on function, and on fabrication at the same time. It combines it in one platform. So it combines how something looks like, how it performs, and also how we will make it, so how we get into the outcome stage of producing things. And this is another close-up. It looks there quite a bit like a regular computer-aided design tool, and I mean, it follows that same structure, but it has a lot of this product management and collaboration tools built in. And I hear very often that people then say, oh, that looks like Facebook. And indeed, it was, I think, not by intention, but the surface and these parts of how you work in groups and how you create groups has a lot to do with collaboration and how to exchange information. And this typically is then, because Facebook is done very well, it leads also always in this direction. And it's more and more important that this this component of collaboration and information exchange in faster information exchange in a product, in a development process, takes a more and more important role in this whole industry. And another aspect is it is accessible through this cloud on many devices. So you have your actual development that you work with on your PC, but it's accessible even on your iPhone. And if it goes about approval processes, about processes of showing it to somebody else, you have access to it on an iPad, on an iPhone, and you wouldn't typically construct on an iPhone, not really, but you can do a lot of surrounding processes actually on other devices, on all the mobile devices, as you, especially your generation, is used to do it basically every day. So for an old construction engineer, he will say, oh, I don't need all that. But I mean, for even now my generation, assuming I try to stay young and open to these technologies, that's very fascinating. And there's another aspect about fusion. If you look at that picture, that is actually what also the cloud offers automatically. That's a very high level ray tracing, and this ray tracing is created in the background. So while you're working on objects, and we assume we have this endless computing power in the background that can fulfill tasks for us, fusion assumes while you're working what might be an interesting perspective for you, or you can also define some favorite angles and perspectives. And while you're just working on this, fusion generates high computing intensive ray tracing pictures in the cloud. So at the end of the day, you have a library and you can browse through the library and you have ready-made pictures that used to take a lot of time to generate and to create. So this is something that is also a big benefit that comes with that cloud operation. And another from the professional side, if we look at that, you all have heard of PLM. It's an acronym for Product Lifecycle Management. So Autodesk has a new tool that belongs to this generation of cloud-based products. That's PLM 360, and this is not so much. It's more for when you work in the professional world, but it's the same idea of having, while there is a lot of PLM has been around for many years as an idea and as a process. And there's many companies that invested millions of dollars in PLM systems, and kind of the feedback is always, they don't work well. So they're too complicated, they're stuck, it's too difficult to administer them. And so Autodesk has created now a cloud-based PLM system, which is growing very quickly in the market, especially also with smaller companies, startup companies, that works in the cloud, where all these companies that work together among each other can use that cloud, like you use Dropbox to exchange things with your friends, and have a very, very clear and easy to use and easy to set up, and especially also affordable way to manage and store data. And one of the interesting things there is also that this PLM system also runs on all the devices. So you have it on your iPhone, you can do approvals on your iPhone, you can do quality check approvals on different devices. And I don't know if it's good for life-work balance in the future, if everybody can approve everything, even on a Sunday. But that's the way where it's heading to. And in conjunction with that, if you go to the education community, I know you probably all are part of the education community of Autodesk, where you get the software for free. I think Dimitri wanted to mention that still. I take it for granted that it's basically known here that Autodesk has that community where all the software is for free for students and educators. There is a new tool that we're just bringing out as a general platform. It's called Autodesk A360. And also as a student, you have several gigabytes of free storage. So every student that signs up has free storage there. Alexei, do you know how much storage every student has? 5 gigabyte. 55. 25. Ah, you see, it goes so quick, I cannot even keep up. So you have 25 gigabyte of storage, but especially you have also that communication platform tied to it. So you're part of that, and you can create your own projects, you can create groups, you can work in groups, basically similar to what you possibly would do in Facebook, but it's a different, it's more professional environment where you also, as student groups, can use this platform to organize a project and organize your data. And this is something that the industry is also very interested in, and we have a lot of response to that, that we, from our knowledge of how things are constructed and how things will be going in future, that this is actually the way of how people today want to communicate. And so there is all that very interesting aspects that, as I said, that look like Fusion, and it's about project, it's about data, it's about people that work together. So let's come to the last part of our 4 topics that we actually wanted to have a look at. That's a very interesting one. That's the create part. How do we get the stuff out of the computer in new ways? And we basically have 4 ways today of manufacturing, 4 ways of making things. And one is additive manufacturing, which is, additive is typically the 3D printing. Subtractive manufacturing, which is what is classic as the CNC milling. You have one block and you subtract things to create something new. And then we define the third one as the robotic assembly and also robotic handling of and formation of things. And the fourth one is a very fascinating, sometimes frightening. It's biological. It's how can things created in a biological way, ideally in a very predictable biological way. And this is a lot in the press these days, and you have them also in the Fab Lab. It's about the consumer 3D printers, and they're very, very successful all over the world. And in most of the cases, I saw very, very interesting, like the robot hand in your Fab Lab. So also these plastic parts that are not so precise are very good in to be used. It's used from a lot of people for creating toys, like little cars. That's cute, but this is not really what Autodesk is aiming at and looking at here in this field. So we're really looking at how can industrial production be improved with technologies of 3D printing. And there is a multitude of manufacturers that are creating 3D printers these days and all kinds of different ideas. It's a bit like the situation in the early 80s with the PCs, with the computers, where there was a very, if you look back today, the iPhone or the mobile phone that you have in your pocket, that's stronger than 30 years ago, a big supercomputer that was maybe filling a whole room and needed energy immensely. And so it was just 30 years to change that. And I think it will be even faster in this 3D printing sector that we will see totally different and faster printers as there are today. And it's already amazing what's going today. This is a printer in the below $10,000 area that prints composites, plastic and carbon fiber, which makes then, of course, a much more durable and lightweight, but and also a stronger material and objects. And this is where things, together with metal printing, where it goes. That's actually an artist work, very fascinating. It's also metal printing, and it's some artists in Holland that work with this technology, with robots and with metal printing, or it looks actually like welding. So, well, metal printing is nothing else than, it's another form of welding. If you weld, you actually also print metal. You put metal layers on each other. And this is very fascinating from the way that we also at Autodesk, we invite also artists to come to our headquarters in San Francisco working on projects, because they bring in a totally different perspective that often leads to new technologies where no scientist actually would find that. And this is also interesting in terms of what I see also here at the university, that you have very many disciplines, different disciplines working together, and so that you create new ideas. That's another fascinating example. That's from the University Stuttgart, from the faculty of computational design, Professor Menges, and he works with robot producer KUKA for finding completely new ways of producing things. And here they take a fiberglass web and create structures that then end up to be very futuristic, like these, and using totally new technologies in terms of having a digital model and then interpreting it in a new way of fabrication. This is now more art than it is probably, and it's a pavilion, more art than it is architecture, but it leads in a certain direction, and they're doing very interesting things. So if you look at that, that's a bit more of a simplistic view. That's a 3D printed house. I think there's still a lot of room for improvement. So, but it goes in a certain direction, and it shows certain paths of, like with the first computers, where people were saying, I can't use that, it will never go somewhere. If you see where it went in the last 30 years, I can imagine that there is totally different 3D printed houses around in maybe 10, 15, 20 years. Just looking at new technologies and how to do things. Another example that our CEO loves, that he has that machine actually at home. Carl Buss is a maker on its own. It's a combination of printing and CNC milling. So you actually have metal printing, but because metal printing is never so super precise than CNC milling a metal, DMG Mori, a German producer, this is why this is all in German, is basically doing this combination. So they first print metal, and then they refinish it with CNC technology in one machine. So it's this arm is actually just changing between printing metal and then taking the milling tool and then refining it. Very, very interesting stuff that opens totally new production ideas because you can print things that you cannot CNC, but you can possibly refine it with the CNC just on the surface. And so that's very interesting. And a third one just is about, this is the Museum of Modern Art in San Francisco. And here it's also this facade consists of 800 pieces, layer panels that are all unique, and they're all actually CNC. The mold was CNC generated, milled, and then actually filled with concrete or whatever material they're using there. But it shows the possibilities with the computer of, even if it's just a one-off project, it's just a unique thing, it will never be, it's not a serial product. It's worthwhile or it's possible with these computer technologies today to create sculptures in the built environment, in the cities. You will hear very soon, or it's actually announced already, and it's quite interesting because the Faculty of Computer Sciences is also very much working with software development. We announced a new initiative and a new software platform that's called Spark. And Spark is actually a software platform for 3D printing. And it's an open platform, an open source platform. Today, maybe you've experienced that in the Fab Lab. It's not always predictable. You have a 3D object that it comes out on the 3D printer the first time in the exact way as you wanted it. And this is because that's still some limitations on that. And Autodesk has now started to contribute a platform with a freely to distribute software technology that can be adopted from anybody, from students, from scientists, from companies, also 3D printing companies, to be used as their middleware, as their basis for, it's a bit like, if you know Adobe, like EPS of Adobe, which is the standard of PostScript of printing. So most prints are generated in EPS. So Autodesk is now wants to establish that new format for 3D printing. It's probably several that try that, but I think we have a lot of knowledge around that. And together with that, Autodesk has also, that will come out, I think still this year, an own 3D printer. It's a photoresin printer that Autodesk has developed, but the idea is not to now jump into becoming the biggest printer producer. We're staying on the software side mainly, but it's about having that reference combination of our software Spark and a 3D printer that shows how things can develop smoothly and how they work together. And the demand for the printer is amazingly high. I think those are all already sold out that have been produced right now. And the interesting thing is Autodesk does not make any secret about the printer. So the whole construction plans of the printer and even the sourcing, where did we buy the parts and how do the parts look like, what technology is this, is all free available. So everybody can take this and build his own printer or use that as a basis for building new material and new technologies. And the idea behind that is really to accelerate the professional use of the printer. And of course, our idea behind that is also that for using a printer, there's always software that is needed to create something, and this is, of course, our main area. I mentioned a bit just at the end of the 4 points of creation, the biological creation. So that's a pretty wild field right now. Also very fascinating. This is the Museum of Modern Art in New York, and there is some scientists or some artists and scientists that built that structure out of mushrooms. And so first I thought, and it's biological material, okay, so why they could have done with wood. But then I realized, okay, mushrooms grow much faster than wood. So that's a material that grows in a fraction of a time that it would take to grow a tree, and is the first entry into quick production in a predictable way of biological material to be used other than wood, to be used for construction. I wouldn't like to live in this place, but it also goes in a certain direction on that you suddenly have different material. Another example is what Autodesk is working with Harvard University, with the WIS Institute of Harvard University, that goes in the nanoscale. And this is a nanoscale robot. And I think I've heard that you're also here at the university dealing with nanotechnologies. So this is actually made out of DNA strings, and it's like a clamshell, like in the ocean, but with a hinge, so it can open and it can close, and it's very fascinating. The idea is that such a nanorobot attaches to a cell and opens it and delivers drugs right to the cell where they're needed. And if probably in 30 years, if kids will ask, how did you treat the people back then, it will be like we think about 100 years ago. We would say, yeah, we gave them some drugs and that poisoned the whole body, and we were just hoping that some of the drugs reached the right point to have a treatment, especially with chemotherapy. And this is, the DNA does not actually carrying information, but it's just a structural element. And somebody explained it to me. It's actually, it's not easy, but it is doable to, if you bring the right components together, they self-assemble automatically, natural to that what you want to have. It's definitely still a long way to go there, but it's a very fascinating field where we hear more and more advances in technology. And this is an acorn, and this also, just to finish up, that's an interesting symbol. It's that the information content of such an acorn is about 1 gigabit. So it's 125 megabyte of information that is contained in that acorn, and it's about what contains everything to actually grow a tree, and it's about decoding. So what in some people also are very concerned about it, but there's a lot of opportunities in that to decode the DNA of plants and to twist it to have them perform in a more predictable way. And this is very, very, very way into the future, but I think a lot of people are working on that all over the world, in Russia as in the US, as in Germany, I think. And it will open a way to have materials that, like this acorn, actually create out of this a huge tree, to have totally new things to be created in the future out of biological material. So that was a little fly through some of the thoughts that Autodesk are working on. So I really thank you for the early afternoon for staying awake and listening to me. I hope it was some new aspects maybe. And I really enjoyed my stay in St. Petersburg. I will rush. I have 15 more minutes till my taxi comes to head back to Germany, to the airport first, and then flying back to Germany. And I wish you all good luck in your studies, and that you can take a lot of benefit from these technologies. And we have great teachers here that are very capable in teaching you these new technologies, and very open to teach you the future, not to teach you the past, but teach you tradition, but teach you especially the future of these technologies, and that will be your key to be successful in industry.